Hello! So today we're going to review this RC circuit from homework 4. So it says the switch A was closed and switch B was open for a long time before t equals 0. So we'll have that was in steady state, and that all the voltage and currents had stopped changing. Then at t equals 0, switch A opened, and 10 milliseconds later, switch B closed. So let's start with finding I of x at 10 milliseconds minus. So I'm just going to draw out. A was open, so I'm not gonna neglect the left side. And B is currently open. So Ix will just be 0 because there is nothing happening beforehand. So for Ix 10 plus, I'm just going to redraw the circuit with SWB closed. So first I'm going to define the voltage across the capacitor and solve for the voltage before at 0 minus. So we'll have that it is 5 times 3.3k ohms to get the voltage across the capacitor at 0 minus. This will give me 16.5 volts. In order to solve for VC, I'm going to use 1 over the capacitance of the integral from 0 to 10 of the current plus the voltage at T naught. So I'll have the capacitance minus 5t from 10 to 0. And this will give me, so this gives me negative 0.6097 times 10 to the negative 3 for the microfarads times 10 to the negative. So that'll give me negative 6.97 volts. And this will be the voltage at 0. So we will use this to find the voltage across the capacitor at 10 plus, so we'll have 16.5 minus 6.97, which is equal to negative 22.59. So now that we solve for the voltage across the capacitor at 10 plus, we can solve for Ix at 10 plus. So this will be the voltages over the resistors. So we have 12 minus the capacitance voltage we found over 470 plus 560. I accidentally write kilo ohms instead of just ohms, but after we do the calculations, you'll end up with negative 10.2888 milliamps. So 0 and negative 10.288 will be our 10 plus and our 10 minus. So in order to find the energy stored in the capacitor before t equals 0 and after t equals 0, I'll be using the energy formula, which is 1/2 times C times V squared. So we'll have 1/2 times 8.2 microfarads times the voltage of the capacitor that we found times negative 22.587 volts squared. This will give me 2.093 millijoules for the energy stored at t before 10 milliseconds. For after 10 milliseconds, I'll use the same equation and get the same value. Thanks for watching. Bye!